issue. Yep, that was in fact bad for it. That was in fact bad for it. Alright. Well, that was fun playing Flight Simulator, guys. It's 4:30. How about some space news? Wing Int. Yep. Little pain, little meta work, it's fine. It looks like the, you guys see that video of the 747 that crashed into the hangar? It was for a movie, so it was kind of on purpose, but we'll buff out. That was fun, dudes. We'll get back into regular flights soon. Can we fly the Concorde sometime? Yeah, maybe. There's already a Janet livery. Nice. Just another non-existent terminal. Alright. Well, I had fun. I hope you guys had fun. We'll play more Flight Sim in the future. Absolutely. So, I'll be right back, and I'm gonna get us ready for space news. Let's peep the video. Do you know anything about Flight 191? Yes, and I don't want to talk about it. So, we have a Starlink mission that's scheduled in about an hour and a half. No guarantees if it actually goes, though, but we'll see. Let's see. Trying to find a good video. Give me 1 second. I usually put on some NASA Public Archive footage here. While I take a lunch break. Have you ever printed in TPU on your printer? I don't know what that means. Yeah, Maverick, I don't know what that means, dude. You know what? You get nuclear propulsion today. I showed it very recently, but I want to watch it again. I'll be back in a little bit. Enjoy the video. Emotional damage from this. Be right back.
The moon, closest neighbor to Earth. Presently the focus of man's greatest scientific adventure, the first celestial body that will be explored by man. Landing men on the moon will be a truly great achievement, but only the beginning of a new era in space exploration. No one can predict the exact missions that will follow in the years and decades ahead. But the most exciting possibilities will require the acceleration and deceleration of very heavy loads, such as the maneuvering of large Earth-orbiting spacecraft. The transportation of large amounts of equipment and supplies to the lunar surface, and the sending of heavy spacecraft to the planets. Today's missions are being accomplished with rockets that burn chemical fuels. But chemical fuels are heavy, and the cost of putting each pound into Earth orbit is very high. Nuclear rockets, when perfected, can provide the same propulsion energy with less overall weight. They will expand our ability to explore space. this is the story. This is Saturn V, the most powerful launch vehicle being built by the United States. A three-stage rocket that will place the Apollo spacecraft in the vicinity of the moon. The total weight of Saturn V is about 6 million pounds. Its three stages have chemical engines that burn fuel to generate thrust. The first and second stages provide most of the energy needed to put the third stage and the payload, about 250,000 pounds, into Earth orbit. At present, only chemical rockets can provide the high thrust needed to do this job. The third stage accelerates the payload to the velocity needed to get it to its destination. Here, travel time and payload weight are determined by the efficiency with which the propellant is converted into thrust. By substituting a nuclear third stage for Saturn V, the velocity of a given payload can be greatly increased, cutting travel time for some missions in half. This is particularly important in sending deep space probes to Jupiter and beyond. Or if shortening travel time is not essential, propellant weight can be traded off for an increased payload weight. This is important for a lunar supply mission, Earth orbital operations, and some unmanned missions to the planets. Why is the nuclear rocket so much better than the chemical rocket? In rocket propulsion, exhaust velocity determines propulsion efficiency. At a given temperature, the lighter the exhaust gas, the higher the exhaust velocity. And the higher the exhaust velocity, the more thrust is generated for each pound of propellant consumed per second. The nuclear rocket merely heats hydrogen, the lightest element of all, and expels it at tremendous velocity. Chemical rockets burn fuel to produce exhaust gases that contain heavier elements. So at the same exhaust temperature, the exhaust velocity is much lower, and each pound consumed per second produces less thrust. Rocket efficiency is stated in seconds of specific impulse. This refers to the time in seconds that 1 pound of propellant will deliver 1 pound of thrust. The higher the seconds of specific impulse, the greater the propellant economy. Our best chemical rockets of today are limited to a specific impulse of about 450 seconds, and only slight improvement can be expected. On the other hand, full-scale nuclear reactor tests have achieved 800 seconds, and laboratory tests promise even more, perhaps as much as 900 seconds. This means the nuclear rocket, with its lightweight, high-velocity exhaust, will use propellant about twice as efficiently as chemical rockets. This, then, is the principal advantage of nuclear propulsion.
It was at the AEC's Los Alamos Scientific Laboratory, high in the mountains of New Mexico, that the first steps were taken. Here, in the mid-1950s, scientists set about to determine if nuclear energy really could be used to provide rocket propulsion. Theoretical studies and early experimental work revealed many problems that would have to be solved. Problems in reactor design, material, radiation, structures, control, to name but a few. The nuclear rocket was found to be feasible. A series of experimental reactors was planned to convert theory into workable hardware. Optimum reactor designs were worked out by analysis. Prototypes were built. A comprehensive test program was started. These reactors, called Kiwi, were to be used to prove out design and operational concepts. They would be built only for ground testing. All Kiwi power tests took place at the Nuclear Rocket Development Station at Jackass Flats, Nevada. Here in the desert, scientists and engineers checked the actual performance at various power levels and for various time periods. Each experimental Kiwi reactor was received in sections, assembled and checked out in a special reactor maintenance, assembly, and disassembly building called simply RMAD. When the reactor was ready for testing, it was placed nozzle up on a special rail car and delivered to the test stand a mile or so away. This car could be controlled from a remote station. Liquid hydrogen from nearby storage tanks was pumped through the reactor. First tests were begun in 1959 and were run to the 100 megawatt level, about 1/10 of Kiwi's ultimate goal of 1,000 megawatts. Later tests, beginning in 1962, operated at the full 1,000 megawatts. Films of these early tests show the flaming torch on the test stand that burns off the hydrogen exhaust gas and prevents an explosion hazard to the test facilities. Upon completion of these tests, each reactor, by then radioactive, was transported by remote control back to the RMAD building for disassembly and inspection. Here, men working behind shielded walls used remote-controlled manipulators to remove the components for careful checking and analysis. Each test firing added information that helped scientists evaluate the reactor's performance and enabled them to make adjustments and corrections before the next reactor was assembled. But not all tests showed perfect performance. In this one, for example, the flashing in the exhaust gas indicated a structural breakup caused by excessive vibration. Extensive redesign and testing were needed to correct the flaw. And in this test, a hydrogen leak caused a fire on the test stand. Again, a correction was made. Each test brought the scientists a little closer to the performance they were seeking. Until finally, in September 1964, the 8th Kiwi reactor was brought up to full power and held for 8 minutes. And a few weeks later, it was restarted and operated at full power for 2.5 minutes. Specific impulse, about 750 seconds. This concluded the Kiwi test series. It had proved that a nuclear reactor could be built that would power a spacecraft.
The next step, already underway, was to develop complete engine technology. This project was called NERVA, Nuclear Engine for Rocket Vehicle Applications. It was to be a combined industry-government effort headed by the Space Nuclear Propulsion Office, a joint NASA and Atomic Energy Commission activity. The principal contractors were to be Aerojet General Corporation and Westinghouse Astronuclear Laboratory. The NERVA technology reactor, given the letter designation NRX, was essentially the same as Kiwi. But now the contractors had to extend its lifetime and put it into an engine configuration. Here is how the nuclear rocket engine will work. The reactor is a solid core, heat exchange type, cylindrical in shape. Fission of uranium atoms in the core is the source of heat. A reflector made of beryllium surrounds the core. The core consists of many graphite elements impregnated with the uranium-235 fuel. The core contains a number of channels running down its length. Hydrogen passing through the channels picks up heat generated by the fission process. The channels are coated with niobium carbide, a material which resists the corrosion that would occur if the hot hydrogen were allowed to come into direct contact with the hot graphite. The hydrogen is stored in a liquid state to achieve the lowest possible volume. The flight model will use about 1/3 of a million gallons for a 30-minute firing. To start the engine, the cold liquid hydrogen at -420 degrees Fahrenheit moves through a pump down to the nozzle, through internal passages in the nozzle walls, and back up inside the reactor pressure shell and reflector. This cools the nozzle, the reactor shell, and the reflector, and at the same time warms the hydrogen. The hydrogen then passes through the hot fuel elements where it is heated to about 4,000 degrees Fahrenheit. From there it is expanded through the nozzle to provide thrust. The bleed line carries some of the hot hydrogen back to drive the turbo pump. The whole engine system is amazingly compact for a nuclear power source. The reactor works through fission of uranium-235, which constantly emits nuclear particles called neutrons. When reflected back toward the reactor, these particles will set up a chain reaction, generating terrific heat. The heat is controlled by rotating rods installed in the beryllium reflector around the reactor. The rods are also made of beryllium, but one side is coated with boron, which absorbs neutrons. Initially, the rods are turned so the boron side is toward the fuel elements, and sufficient neutrons are absorbed to prevent nuclear fission from starting. Beryllium reflects neutrons. By turning the beryllium side toward the elements, a point is reached where sufficient neutrons are reflected for fission to begin. The amount of heat produced depends upon the position of the rods. Heat increases as more of the beryllium side turns toward the core. When the desired rate of heat production is reached, the rods are turned back to stabilize it. Heat decreases as the rods are turned back. When the boron side absorbs enough neutrons to halt the fission process, heat is no longer generated. These rods can be operated by remote control.
Test facilities for engine components were built near Sacramento, California. The problem? Get adequate performance with minimum weight. The pump must move huge quantities of liquid hydrogen under pressure at -420 degrees Fahrenheit, while the hydrogen-cooled nozzle must expand high-pressure gaseous hydrogen at 4,000 degrees to low pressure. The reactor was designed to meet the structural requirements of ground handling, launch, and spaceflight. In a late 1965 test, it operated intermittently for an hour, including 16 minutes at full power. But in that test, as in all reactor tests before it, the hydrogen had been forced through the reactor by test stand pumping facilities instead of its own turbine-driven pump. In early 1966, the new technology reactor and the chief engine components, including the turbo pump, were assembled for test. It was called a breadboard because they were not arranged as they would be in an actual engine. It would be the first self-starting test, and it was a vital step in the nuclear propulsion concept. This engine test model started perfectly and increased to full power, proving that a nuclear rocket could be started by its own pump. During a 2-month period, it was started and stopped 10 times and operated at different power levels for a total of 110 minutes, 28 minutes at full power. Technology had now advanced to the point where performance limits could be extended. Work was already underway to increase reactor power and operating time. In February 1967, this reactor, the Phoebus 1B, was operated at a power level roughly equivalent to 75,000 pounds of thrust. And in December 1967, this reactor, the NRX A6, was operated at full power for an hour. Also in 1967, a new test stand was completed that would permit a test engine to be fired nozzle down into a vacuum chamber below, at least partially simulating the space environment. In early 1968, the first ground test engine was mounted in the new stand. Its success was a new milestone along the long road leading to a flight engine. Heavy shielding was used in this test engine to protect some of the components from intense radiation. In flight engines, all components will be radiation hardened and less shielding will be needed. These tests will complete the technology for a nuclear rocket engine for application to space missions of the late 1970s and beyond. Its thrust will be approximately 75,000 pounds. For missions that require higher thrust, 2 or more of these engines may be used in a single stage, or several engine stages may be assembled side by side. This versatility will give us the capability to perform a variety of advanced missions.
Someday, a manned trip to Mars and return may become the mission assignment. Exactly how it would be carried out depends upon a number of factors. But here is one way it might be done with nuclear rocket propulsion, using the technology developed for earlier missions. Using several Saturn V launch vehicles, components of the huge spacecraft would be placed into Earth orbit and assembled. Separate nuclear stages might be provided for each major step of the mission. The first stage might consist of 3 clustered rockets for departure from Earth orbit. 2 other nuclear stages consisting of 1 engine each would be used in the vicinity of Mars. The first stage cluster fires to accelerate the spacecraft to the velocity needed to get to Mars in the time that was decided upon, say 200 days. At burnout, the first stage cluster is jettisoned and goes into orbit around the sun. Mid-course correction is made by chemical rockets. About 200 days later, the space vehicle approaches Mars. There it is slowed down by a single nuclear rocket and enters an orbit around the planet. The used second stage is put into a higher Mars orbit than the space vehicle. A chemically powered module departs for the planet's surface. For the first time, men from Earth will set foot on another planet. For the return trip, the module is lifted by chemical power back into a Mars orbit, where it docks with the main space vehicle. The men transfer to the main craft and jettison the module, leaving it in an orbit around Mars. A third nuclear rocket accelerates the vehicle for the return trip. And it is jettisoned. Again, mid-course correction is made chemically. Just before reaching the vicinity of Earth, the crew transfers to a re-entry vehicle and jettisons the large spacecraft. Chemical rockets slow down the vehicle to re-entry speed and they are jettisoned. After deceleration through the atmosphere, the re-entry vehicle returns to the Earth's surface by parachute. A trip to Mars and back, for centuries a dream of earthbound men, is now much closer to reality. Of course, there are many, many other problems to be solved before such advanced space missions can be attempted. Life support systems for extended space journeys, more accurate space navigation, communication systems, power supplies, and so forth. But any successful advanced mission must begin with propulsion, the power to get there and back. Lower overall weight, larger payloads, shorter travel time. These are the chief advantages of nuclear propulsion. The technology needed to build a nuclear rocket is well advanced. It will be available when this nation determines its next great objective in space.
So when's that happening? When is our next great... No, the Artemis program should do it. Part of the Artemis program is bringing NERVA back. Seriously, a company named BWX Technologies is working on NERVA right now. They released a picture of what the engine's supposed to look like the other day, which is actually pretty freaking cool. So, yeah, I mean... That video is great, man, but yeah, it's, they had it working. It was working. Thing was, we have new NERVA, dude. I'll show you. BWX, yeah. It's down here somewhere. That's not a rocket, but that's still cool. There it is. There it is. New NERVA, baby. It's got the same radial control rods. Same thing. SpaceX audio is online. Right on. The NERVA of some people. Yeah. There it is. It looks like it's got this version has a nozzle extender on it, but yeah. Pretty sick. Flowing hydrogen over a nuke to cool it can give you propulsion. That's actually really smart. NUVA. Yep. NUVA. It drives single turbo pump. That's all you need. One turbo pump. That's it. And the turbo pump is driven by heating hydrogen for cooling the nozzle. It is smart, man. That's really smart. My prediction: this will NERVA fly. Emotional damage. Boo this man. All right, let's see. Let me look around. Let's see what's going on with space news. Jeff Bezos admits that space squirrels are in fact real. Yep. How far did LOX boosted nuclear engine tech go? Sorry, I lost my train of thought. LOX boosted engine, I don't think they ever used liquid oxygen. It's corrosive. You don't want to rust the inside of a nuclear reactor. I just don't think that that's a good idea. But I don't know. I don't know for sure. Hi, Mr. Bezos. Please lend me one of your spaceships. I would love to experience the wonders of space and see if space squirrels are real. Space squirrels are real. Alright, so we got some footage from Jenny. This is... What's Jenny up to? Jenny's a photographer for Supercluster. Let's see. Hear me out. Locks afterburner. Diminishing return, but it could work. See? See? You want to be as classy as this man right here. You want to be as classy as this man. Look at this man. See? This man. Classy. SpaceX. And Ferd. That's pretty good. Muted? Here, I'll turn it up a little bit.
Hi, Jenny.
Hi.
Right.
How you doing?
Pretty good.
Good to see you.
Good to see you guys.
You motivate us.
Yeah.
Wait, what did he say? I don't. What did he say?
Good to see you guys.
You motivate us.
Yeah.
What was that last thing that he said? I don't know. Brought something else. Hey, Banana Time, what's going on? Wubba dubba. Yeah, okay. Motivator.
Good to see you.
Good to see you guys.
You motivate us.
You motivate us. All right.
That's so great. That's so sweet.
Classy. That was a very classy interaction. That's coming from Jenny Houtman on for Supercluster. The Kometo sounds awesome. That's one of my favorite space vehicles that doesn't go to space. So we have some stuff from Jeff Faust there. So that was the booster coming back that flew that was Starlink. That was the Starlink mission. That was the 12th reflight for that. Hey, Seacracken, what's going on? Yeah, Jenny was, the reason she's in the wheelchair is because she's going through PT. I don't want to talk about it too much. She had a nasty car accident. Like, yeah, she's, we are lucky she's still here. Let me put it that way. So, yeah, that's why he said, that's why you motivate us, because she's been back taking pictures for Supercluster and doing PT at the same time. So it's pretty cool. Pretty cool. She's one tough mother. What happened? Car accident, Maverick. Guy fell asleep at the wheel and drifted across the road and head on. It's bad, dude. You don't want to see it. It's not good. It's one of those accidents where you're just like, oh. She's almost always there to see the boosters leave port. Yep. Yeah, no. This was during the Lucy mission. So this was not that long ago. The fact that she's back up and kicking is just, she's tough. It's pretty inspirational stuff, man. So, yeah, no, I'm glad she's all right too. Yeah. And she takes good pictures. Like, there's also that. There's the whole, I sent you something cool to Discord. Check at your leisure. Okay. Yeah, Sparky. I've been linked this probably like 20 times today. Yeah. Yeah, Hibbit, I know, I don't know Jenny personally, but I know her through a bunch of the spaceflight photographers that I know down there. It's like once removed, right? But yeah, no, I saw pictures of the car, and it's not recognizable as a car. It looks like if you took a car and put it in a blender. Yeah, so, I mean, the fact that she got pieced out of that thing, and, I mean, the fact that she's still in one piece is just inspirational stuff. And she's like, no, I'm gonna go take more pictures. It's a testament to willpower right there. But anyway, that's why those guys were like, you motivate us, which is cool. Because, no, she's out there all the time taking pictures, which is cool. That's pretty sweet. Pretty sure that the Model 3 literally saved her. Any other car would have been way worse. I mean, yeah. So, okay, like I said, I'm not showing the pictures. It's messed up. Car guys, listen up. The A-pillar, you know, A-pillar on a car, right? So this is the hood of a car. A-pillar. The head-on was so violent, the A-pillar was like this. So the windscreen did a 120-degree flip forward. That's how serious that impact was. Yeah. The A-pillars on the car were facing this way. And the firewall, which is like this, is facing that way. So if this is the A-pillar and this is the firewall, right? It went whoop like that. I've seen the pictures. It's we are lucky that Jenny's still with us, man. Yeah. So car guys will understand what I'm talking about. Everybody else, trust me, you don't want to see the pictures. Anyway, let's go on to the next thing. So this is coming from Jeff Faust here. Check this out. So Huntsville International Airport in Alabama is now an FAA licensed spaceport. Specifically, it has an FAA Commercial Space Reentry Site Operator license that would allow Sierra Space's Dream Chaser to land there. Ooh! Alright, let's, we were looking at Huntsville a lot yesterday. Let's go look again. Allow Dream Chaser to land in Huntsville. Where's the airport? Over here? Okay, man. And then there's another runway right here that's next to Marshall. But, yeah, I'm pretty sure that runway might not be long enough. Cool. So that's over here. That's not that big of an airport, huh? Oh, what's going on over here? Oh, an intermodal depot. Cool. It would be the right airport. The right airport at the airport. I found your channel while I was in PT. Oh, right on, man. Well, hey, I appreciate it. I'm glad. If I helped at all, I'm glad. Yeah, that's a little tiny airport. A little tiny boy airport. It would be the right runway. Okay, cool. So Dream Chaser is could be certified to land there. That's pretty neat. Well, that's pretty neat. Brooke was the top donator to her GoFundMe. It's nice seeing people use their money to accomplish good things, isn't it? Yeah, no, yeah, Jared, yeah, he paid for all her medical bills, like, straight up. It's a freaking G move right there. That's what happens when you have frick you money. Anyway. All right, XTC, 20-month resub. Thank you very much. 3-kilometer runway. Those runways don't look too incredibly long. Let me take a look. So we have 12 hash marks, so 12 hash marks is 150 feet wide. Yep. So we're 150 feet wide, and what are we threshold to threshold here? Oh. It's a 10,000 foot runway. Well, close. That displaced threshold makes it 9,800. But if the threshold was back here, it'd be exactly 10 on the dot. What's a 10,000 foot runway doing there? I mean, that's enough for Dream Chaser, sure. That's not enough for the shuttle. The big space shuttle, the real one. That would be very difficult. What airports could the shuttle land on besides KSC and Edwards? There was a bunch of sites that were certified for shuttle landings, T-Man. Is it a military base? It probably was an army base at some point, if I had to guess. Yeah, if I had to guess, it's probably a military base. Let me look. Let me take a look at the design. Yeah, with a big ramp like that. And look, the key is to look around to see if there's anything that looks like base housing around here. Nah, not necessarily. SpaceX audio control loop is live. All right. You guys wanna? We'll put that on if you want. Live loop is on. There's a military base very close to the airport. Yeah, there's a base over here with helicopters. It's got that's definitely Army. I mean, Huntsville is an Army town for the most part, guys. You got some trainers over there, 4 CH-47s and 7 UH-60s. It's a helicopter base. But so Chinooks, CH-47s, Army, U.S. Army. Yeah, I'm wondering that a 10,000 foot runway is freaking huge, though. That's a big runway for that. Here, I'm just curious. Let me just see if we can get some timeline pictures. Nope. No, that's they just built two 10,000 foot runways. Okay. Oh, they extended them. Yeah, okay. They extended the things. They were two 9,000 foot runways. See? And then sometime between 85 and 97, they extended the runway. Now what's over here? So they set up an intermodal depot right there. Interesting. Do you know what this week needs? More Starlink launches. I mean, yeah. I wonder what that is down here. What's the length of DBI? 9,000. Hibbit. You're spying. No, I'm not. Daytona, here we go. Daytona. Okay, so this runway here has a displaced threshold. $9,800. 9,800 again. Okay. This is where Embry-Riddle is. Embry-Riddle's over here somewhere. I think that's the campus right there. Interesting, Crash. Okay. Huh. Yep. Ah, racquetball. There we go. Hazard area is clear at Vandenberg for the Starlink 413 launch. Cool. That's it, EJ. I went there. Practically live on that flight line. Hibbit, did you make it through? Honest question. I don't remember. No, Tomas, that's the Starlink launch that's tomorrow. Yeah. No, didn't make it. Oh. Yeah, that may have given it away a little bit. It's hard, isn't it, Hibbit? Yeah, everyone that goes through there tells me that college, you got to live and breathe it, dude. Maybe one day I'll find my way there, but if I do, I am not like that's my focus. It's a lot of money to go there, and if I go there, that's my focus. I'm literally not like I'll barely freaking stream, dude. And you pay an arm and a leg for it. Yeah, I know. I went to the video game equivalent of Embry-Riddle. I went to Full Sail, dude. So I know. Yeah, you gotta love it. I made it, though. I made it through. The Bahamas launch isn't that one either. Unknown when they will use that recovery zone. Oh, okay. So it's another Starlink launch. When I was running an aviation website back in the day, our best candidates were from Embry-Riddle. Yeah. Yeah. It was ridiculous. I was so sheltered growing up. Getting my first bit of freedom in Daytona Beach while I had to be laser focused didn't work out so well. Hibbit, I still don't understand how 18-year-old EJ figured this out. Dude, I don't... When I moved to Orlando, I didn't know anybody here. Nobody. I was here 1,000+ miles away from anybody I've ever known. I was here by myself. And dude, how did I pass? How did I pass? It scares me every time I see my degree progress bar at 50 right now, Steak. How did I make it, dude? Yeah, Chris, literally me right now. How did I pass my junior aero class? I don't know how I did it. And that's like so Full Sail does the same thing. It is quick. You go at it quick, and the information comes at you very, very fast. I think one of the reasons why I can listen so well is because if you don't listen at Full Sail, you fail miserably. A lot of people failed. I think when we started in September of 06, I think in my starting class, there was like 120 kids. 20 of them, me included, made it to graduation on time. Yeah, and out of those 20, like 3 of us were 18. And I graduated on time. And out of those 20 people that made it, didn't fail a class, I was in the
Discovery, go at throttle up.
Henry, 24-month resub. I was in that group of 20, and out of that group of 20, 3 of us were out of high school, right into Full Sail, which is crazy,
Discovery,
dude.
go at throttle up.
I know Starlink in the title. Hey, Spark, 5 subs. Dude, how did I do it? It's the same thing, man. How did you do it in...
Discovery, go at throttle up.
How did I do it in Florida? When the shuttle in KSC is like right there. How did I manage? I don't... Like, Disney World is right there. There's so much... Maybe the reason why I like Florida so much is because I didn't do anything when I was there. I didn't do anything. I just worked the entire time. Kind of blows. Yeah, willpower is useful, man. I'd love to go to Embry. If I didn't have so much student loan debt, I probably would have done that already. Student loan debt from Full Sail, might I add. But that's Florida for you. Yeah. It was believed that 415 would use the Bahamas recovery zone. Then they switched to that northeast recovery site. Then it was believed to be 418, but they switched that one to the north as well. So it's up in the air right now. Yeah. Iron Spark, thank you very much. Thank you very much. Maybe I need to do it again. You can do Embry-Riddle remote. I don't know if that's a good idea. I meant a focus, commitment, and sheer freaking will. Dude, I don't know how I did that. How did I not get distracted by something? I don't know. I still can't figure that one out. Aerospace remote absolutely sucks. Chris, call me old school. The last time I was in any traditional classroom was 2008. I don't think I trust myself to do remote learning. If I was going to do remote learning, straight up, dudes, I would have you guys have access to like my course syllabus to hold me accountable to it, or else I know me, it would never get done. You studied 3D graphics, right? Did you learn any programming? There was programming class, Mycon. I took a Python class. Well, not really Python. We used Python for rigging stuff, for rigging 3D models. And then in high school, I took a Java course. Dude, I don't I don't know anything about coding. I know a little bit, but I don't know a little bit to even be remotely comfortable. It's better to say that I have no idea what I'm doing because I don't, you know? You could do homework streams. Yeah, do your homework or the stream stops. Yeah, right? Yeah, exactly. It would have to be like that. It would have to. I'd have to do it that way because there's no other way it's going to get done. If I'm not in a classroom, it makes it so much more difficult. I don't know about you guys. Everybody learns different, you know? I hate Java with every cell. Yeah, maybe, boss, yeah, maybe that's why I took one Java class and said, yeah, no, yeah, I don't need to do this. Everyone hates Java. All right. Well, fellas, there's not much on the docket for space news today, except for this launch that's coming up. So I think what we'll do in the meantime is we'll see what's going on down in Florida. Let's take a look. This is coming from our buddies over at NASA Spaceflight, Nick and Sweeney, and then Bokajika Galmeri, and the NSF robots here. Go give them a sub. Trust me, if you haven't already. Triatus is like, I'm sitting here being a Java dev. Oops. Does that Comp Sci 101 course you're doing right now have C++ content? Yes and no. We've only taken 2 classes, Axiom. We got a little distracted by the house stuff. Have you worked with Unreal? Yes. I can figure out implementation into games, Maverick, no problem. The front end stuff, like putting models in games, doing environments, that's what I went to school for. Easy. Jossie's like, my condolences. Bum 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 bum. Bum, 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 bum. Hexagons are vestigons. Pause, I haven't seen the sneak peek. I'll have to go look. Sad to see S20 go. It belongs in a museum. Wait. They're also rectagons. What'd you say? Maverick with the bits. Pez. Given that's only bolted on, how does that not fall over? Well, oh, there was the mission control loop. Well, see all these counterweights right here? That keeps the center of mass low. Long story short, the SPMT is heavier than Starship. I know that seems a little bit weird, but yeah, that's how it works. Casper, give it a sub to Dad Boy. This guy's controlling it right here. Oh, man, those things are cool. It's still sketch. Oh, no doubt, dude. It's a big old RC car. Indeed. Not this boy. Dat boy. Oh, yeah. You know you want one. I would like to point out the NSF truck right there. NSF truck. Is that Das's? Yep. That's Das's truck. NSF truck. I'm behind it. You ready? Whoop. There you go. Tundra. It's got a 1UZ in it. 350 cubic inches. Non-interference overhead cam. It's alright. It's alright. It's alright. Tundra, yeah, but it's not a Ferd. It's not a Ferd! It is, T-Man. That's Das's truck. So that's what the movable cam is mounted on. Non-interference valves, RB. Yeah. Meaning that the top dead center of the piston and the valve open, they don't hit each other. There's not non-interference. Some engines, when the valve opens, if the piston comes up, so like if your timing chain snaps, the piston will bash the valve. Non-interference engines, meaning that the maximum open position for intake and exhaust valves don't get near the piston's top dead center. Yeah, that's why those Toyota engines last forever. Well, one of the reasons, non-interference. So like if you get a snag in the timing chain, right, you don't ever have to worry about the valves hitting the piston. On like a different type of engine, for instance, right, like take a Chevy, a small block Chevy. You skip a link in the timing chain. Actually, I don't think small block Chevys are interference either. Ford 4.6, that's an interference motor. So if you skip a link in the timing chain and your valve timing goes out of whack, the valve opens, the piston can jam right into it. That's it. No more engine. That will grenade your... This kills the engine. Mike Baylor is reporting, I didn't have a wind speed number, but from our cameras are experiencing right now, it's super windy at Vandenberg. Waiting to see if SpaceX enters per pellet loading momentarily. Got it. That's a lot of damage. Fun fact, cars in Georgia are mostly imported from the U.S. I saw like 15 Mustangs in the past 3 days and maybe 2,000 Priuses. That sounds like here to me. Yeah. Yeah, the mod motors tested, the 4.6 and the 5.4.
Tanks are venting for the start of prop load.
Okay, tanks are venting down for prop load. That's what the mission control loop for that launch is. What is that thing holding it down? A self-propelled modular transporter. Interesting, Bossia. Does a 97 460 have interference? Most of the old big block motors, RB, most old American motors are non-interference. The reason is because they favor low compression, because frick your efficiency, okay? Especially like a towing motor. A towing motor or just something that's mild, yeah, you want low compression. Low compression ratio. But I'm not sure. I don't know for sure. It varies by every engine. You'd have to look. Doosin'. Yeah, Vasi, it's very interesting. Dude, I noticed that in the Ukraine too. I keep seeing cars that I recognize, you know, and okay, frick me for being like this, but yeah, you know, I'm sorry, I think anywhere in the Eastern Bloc and I think all European cars and then some Ladas and stuff mixed in. But seeing like footage, you see like around Georgia, you see around parts of like the Ukraine and stuff, and like Poland, you see just tons of American cars. I'm like, okay, that's all right. I mean, cool. No trucks though, Sun Temple, right? Starlink 30 minutes. I know. Yeah, Ford is all over the place, Biz. Transit vans. I see transit vans everywhere. Prop load has started. Okay. I'll put us in. I'll tee us in the title. SpaceX Starlink launch cover. Ah! Ah! No! No! Gore! Why? This is fine. Europe's cars from all over the place. Interesting. I didn't know that. Like Vazzy, I didn't know that about Georgia. I had no idea. Interesting. Mustangs, though. Am I right? You, too, could have a Mustang. They're nice cars. They're nice cars. And the ones that are over there are probably 2015 plus, because that's when they went global with the Mustang. Ford went global with the Mustang when they introduced the 6th gen Mustang in 2015. Dude, that thing is cool. V8, you could get it with a V8, you could get it with a V6, or you could get a 2.3 turbo. 2.3 turbo, rear wheel drive, independent rear, independent front. It's a fun car. They're fun cars, man. Like, they're not the fastest cars around, but they're fun. Hold on.
Shall call hold on the primary countdown net. Launch control will abort the auto sequence immediately, and operators shall proceed to launch abort steps in procedure 1. Otherwise, brief the CE or LD for non-urgent go, no-go conditions, and they will approve aborting the auto sequence.
Okay, they're going through the safety checklist there for on the countdown loop. Okay. Nah, Hellbore, he's going through safety protocol. If you see anything from now on, you say hold. If anybody says hold 3 times, it'll immediately stop the count, no matter what. Yeah, those look new, but they're mostly bought by rich and not so nice people. Yeah, those kind of people. Yeah, I got you, Vasi. Those kind of people over here drive around Mercedes and BMWs. Yeah. That's right. Have you seen this video? Dude builds a solar powered RC tugboat. No, I haven't seen that, but that's cool. I'll leave it up. Lawyers? I don't know. I'm being nondescript. That way I can't be held Boston came out there for a second. That way I can't be held liable. No. For defamation. I was working on the high bay. We saw the footings for one of those things for this building here get placed down at the Cape yesterday. That was we're pooping on. No comment. So see those tabs on those, what are they called? They're not slabs, joists. The roof joists right there. See how they have the tabs on them? That's where the roof is going. On. There's a hydraulic press right there. Welcome to Hydraulic Press Channel. I am Elon, the system dad. Hello! Today we're going to crash a $1 million Starship first stage in press. It's very dangerous, so we must deal with it. Ceiling joist, yep. Any news on the orbital launch? It's not happening until fall. I have a feeling the FAA thing is going to be done by the end of this month, simulated. And, I personally, this is a gut feeling. I'm thinking late June, maybe early July. Look, SpaceX started ramping up the testing again. You could tell. Look at just look at the pace of everything. Moving 16 around, moving 20 around, bringing 7 back out. Doing umbilical carrier disconnect tests on the pad. They're moving everything around. Something changed. Something changed. Because we see so much activity around here, that tells me that they have an internal date. And judging by how fast everything is going, yes, it is SpaceX. I understand they go fast. I would say June or July for a Starship flight, maybe. That's just speculation on my part entirely, though, simulated. I'm not sure. 16 is becoming refrigerators, so it's being scrapped. Okay, let's take a look around here. So there's some studs coming out of the concrete there. That's a water pipe, I think. I don't know what that is. That looks like an outboard motor that's powered by propane, but I have no idea. It's a nice Peterbilt. That propane deal is for mosquitoes. Got it. What, Thomas? Any word on what 4 and 1 are about, dude? Rumored to be R2 factors. Oh. Well, okay. Let me look at this. So whatever this is. Okay. All right. Look right here. See this right here? See that hole? That's for a forklift. That's for forks for a forklift to go through. Now, look at something here. Whatever this is, the center of mass is offset to the right. How do I know? Well, you don't want to pick up something if the weight is over here, pick it up because it'll tip, right? These points are always equidistant from the center of mass on the top-down axis, right? You see 2 other stud points up there that are over the center, which tells me this top thing comes off, right? You can lift it off with a forklift. But that's in the center. That one is not, suggesting that whatever this is has a mass higher on one side. So, for instance, if some turbine machinery was over here and a nozzle was over here, Thomas, I think you're right. I think these are engines. I think these are vectors. Yeah, that's my guess, because the offset center of mass gives it away. I think those are vacuum raptors. I think that's right. Yeah, exactly, Smirks. You can see right through it. Yeah, Filcher, that's what I like to do. This is why I comb through this footage almost every day. You look for things. And you can kind of string some details together that we might not know. I've been doing this for years, and we could figure out stuff here. Like, trust me, with chat overseeing it and with me overseeing it, because we've been doing it for so long, we could pretty much figure stuff out, which is actually really cool, because then we get to kind of peek at it that you wouldn't get normally. It's fun, dude. Now we just need to rule out all other possible things. Phil, it's also an exercise in critical thinking. One of my big things here is, you know, if you like this stuff and you want to get into aerospace engineering, you have to learn how to critically think. You have to. Critical thinking and rocket science are very intertwined, very conjoined at the hip right there. If you don't, something explodes in the way that you don't want it. That's an important thing to understand. So try to get people into the mentality of what you need to if you want to do stuff like this. Also, I really like pointing out Fords because I like Fords. Okay, see this nice Ford? Yeah, tickle. Get out! Get out of the way, transit man. Hey. Anyway. So it's moving around ring segments right there. Just like the missile. Yeah, we know where the rocket is because we know where it isn't. Yeah, I know, Smirks, right? CJ fondles the truck. Hey, all right? Trucks need love too, okay? That's going to get taken out of context. It's the internet. It doesn't matter. I can't take it back if I wanted to. R1 Vector delivery for comparison. Yep. It looks to be about the exact same offset, Thomas. Okay. Ship 26, aft dome sleeve outside. See this thing? Well, that's a weight. And what they do is they hang these off of the sides to give this more moment when it's on the crane, so it doesn't swing around as much. And also, if they need to flip or something, the counterweight can help you flip it. They usually don't do it for that. It's usually to just give the lifted the payload for the crane to give it more moment. That's why they attach these weights to the side. It's very useful during integration because these things are actually super light for their size. Most rockets are. Once again, it's getting into tank wall thickness and mass fraction and stuff. Yeah, okay, Foz. That's fair. That's fair. See? They're ceiling joists. That's what they're called. See? So, fellas, I still haven't figured out why they have an extra, like, 3 stories up here. My personal guess, like, because look, the gantry crane is right there. You can see it. Because they don't have the cladding up on the side. And the gantry crane tracks are right here. So this gantry crane can move the length of the wide bay, or the high bay, or wide peepo bay. That's what it's called. There's actually 2 of them. There's another one on the other side. But they added another level on top of this. And then they put down a corrugated steel floor. You can see it right there. That corrugated steel floor is usually the type of floor that you put up, like, that's used in, like, skyscrapers. And it means you poured concrete. That means there's concrete up there. So there's a concrete floor on top of the high bay, which I'm not sure why. And I'm not sure what's going on up here because, like I said, look at the scaffolding right here. There's like 3 stories of building on top of the high bay. Another rooftop bar. Mission control is my guess, Vasia. Yeah. Mission control is my guess. Blood fam! 34 months, dude. What's up? SpaceX bar. No, that's the building over here. Dude, look at the size of that building, man. Every time, like, see the people standing up there. They look like really tiny. Oh man, we even got tiny people. Oh, pets. Also, interesting. The roof isn't crowned. It's just angled. It's a slanted roof. The whole roof of the building is like this. Because look at the joist right there. It's see the gap? It goes up, and I'm gonna guess that the whole roof is angled all the way to the other side. How about them Bruins though? I'm not upset. Got to bring it in Game 7 though, homie. See the counterweight? Because flipping this thing is like flipping a parachute over. Seriously, the volume of this and the mass is not really correlative to each other. For the size, it's really, really freaking light.
Discovery.
So they put the counterweights on there to do that. Game 6 for the Stars tonight, hoping to see similar results. We'll see. Let's go Blues. Josh, I will find you. Okay. Another important thing to note here, fellas, that this is a starship. This is the back of a starship. This is the business end. The rocket engines will be right here. Really easy way to tell. There's cutouts for the vacuum Raptor nozzles right there. See it? 1, 2, and 3. Or 3. 1, 2, and 3. So this one will have 6 engines in this configuration. See that? 1, 2, and 3. 3 Vector skirt. Yep. They flipped it over because they're going to sleeve it on a bulkhead like this. Not that one. Not that one, though. Ooh. Yeah, they're putting down the cilia fibers right there with the tiles on top of it. Hey, human, what's going on? Off topic. You could use the equalizer, the AC. Senchai, I potentially will be moving in a couple of months. It's not a concern for me. Sorry, I know. But trust me, we'll if we get the close on the thing, if we put the closer in, we get it. I will make sure that does not happen. Little over T-minus 11 minutes on the Starlink stream. Do you know how long-ish. Contra, it might be to the end of the month. It might be a little bit longer. It's a lot of paperwork, dude. So, when you buy a house, there's a lot of stuff that you have to take into account. Everyone, and this is what everybody's telling me. It's so much stuff that you're going to get stressed out, and then you're going to be excited, and you're going to be stressed out, and you're going to be excited, you're going to be stressed out, you're going to be excited. So, you have to come to a deal. You have to go through negotiations, right? We went through negotiations already. So if you find a house that you want, you can't just be like, yes, I'll take one house, please. Here's the cash. I mean, you can, but since it's such a big amount of money being moved, it's binding. You have to bind it with a contract so nobody gets screwed. Like, it has to be legally binding. So people don't Ponzi scheme houses and stuff, right? And even then, people still do. So you have to go through all the paperwork, everything. Remember how I said everything is negotiable with a house? Like, Primo and I negotiated with our realtor. We negotiated for the people that are leaving or potentially leaving their house, the people that are selling. We negotiated with them to get the washer dryer. I was like, can we, I told my realtor, we told the realtor we want the washer and dryer. So he wrote that into the contract. So we wrote the contract and we came to an agreement. Now the contracts need to be finalized. So that means a lawyer. You got to get a lawyer, and the lawyer has to look over everything. They have to look over everything. They have to make sure the money moves around right with the bank. They have to make sure that the money trail here for the transaction goes well. Basically, they got to make sure that everything is legally airtight.
Discovery, go and drive.
Hey, Spark. 5-month resub. Or not a 5-month resub. Gifted 5 subs. Sorry. As I said it, I'm like, that's not what you say. Thanks, Iron. I appreciate it.
Stage 2 locks load has started.
Stage 2 locks load has started. Thanks, Newt. So, yeah, there's a lot of stuff that we got to deal with. Sometimes closing, because you have to, it depends. It depends on how much, what are you negotiating? Like, are you just buying the house outright as is? Do they move the furniture out? Do you take the washer dryer? Blah, 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 blah. And depending on more, how much you want, like more negotiations, the closing can take longer. You just got to make sure everything's right. So what we've been doing after our offer got accepted is I've been talking to a real estate lawyer. Nice guy. But yeah, he's looking over all the paperwork right now. That's going to be his job for the next couple of weeks. Yep, there's so much, dude. There's all these rules and stuff with buying a house. These guys are just grading out terrain. This is at the propellant site. There's so much stuff with buying a house, and there's so many ways. There's so many ways that you can get burned. So there's like tons of protections and all this other stuff that like buyer protection, seller protection, etc. Okay, that you have to be careful about it, and that's why it takes long. It's a legally binding thing to protect you. You gotta be careful with that. 8 minutes until SpaceX. All right, we will pause this, and I will switch us over to SpaceX coverage. That's the other Starlink mission. Oh, okay. Lawyers suck, man. Yeah, exactly. They have installed the QD faceplate onto the suborbital pad for S-24 testing. Cool. Cool. I don't mind lawyers' use. Lawyers in the grand scheme of things are not the worst. Yeah, I would say necessary evil, It's funny, guys. It's funny because lawyers... Here, I'll switch the titles up. We'll put Starlink coverage up at the top of the title, and then I'll put that over there, like that. Done. There we go. I think that like legal stuff is like a different side of the same coin with like engineering. Seriously, because with engineering it pays to be precise. And with lawyers, it also pays to be precise. I honestly think it's the same mentality, just applied to a different medium. Seriously. Lawyers and engineers are two sides of the same coin. It's the same method of thinking. From what I notice, you really have to be careful when you're a lawyer, and you really have to be careful if you're engineering a rocket, because if you get something wrong, you lose a lot of money. And when you're a lawyer, if you get some of the wording wrong, you lose a lot of money. Am I wrong? Like, same with CPAs. Oh, dude, my accountant likes me. Well, yeah. My accountant likes me because we were talking about like personal finances and stuff a little while back, and I'm like, he's like, you have this, what do you want to do? I'm like, can I do this, and this? And he's like, well, I don't know if I should do that. I go, can I do this, and he goes, my accountant was like, I like you. You have the right mentality for this. I'm like, okay. River turtle. Okay, SpaceX is live here. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. I like you. You have balls. I like balls. Do you think OFT2 is going this month? Yes, FX. We listened to the flight readiness review. They're not working any outstanding line items. The flight readiness review went off without a hitch. A couple of small things here and there with the spacecraft, but nothing too big. We went through the FRR presser the other day. I had to stop at like the last 3 questions, but when will then be now? Soon. For decades, Canadian engineers got a graduation ring made out of the steel of a collapsed bridge in Quebec as a reminder. Yeah, engineering ethics is very, very important. Two new road closures have popped up for Boca Chica. These will be used to move stuff. Tomorrow from 8 a.m. to 9 a.m. and then Sunday from 6 a.m. to 7 a.m. Gotcha. I choose business ethics. The Industrial Revolution to me is just like a story I know called The Puppy Who Lost His Way. The world was changing. The puppy was getting bigger. Hilness, I told you last week, but you may have missed it. I got a title promotion to Senior Services Engineer. Cool, man. Congratulations. Making more money? More money. More money. First off, screw your rocket when you launched it. Yeah, West Side coming equipped with game. Sorry. We'll likely see Booster 7 move back to the build site for a triple Raptor install. Yep. You get your butt out there and find that freaking dog. If the dog is lost, you don't look for an hour and call it quits. Only a little more money, but base pay is now 6 figures. Based pay, 6 figures. Oh, here we go.
Pad is clear.
The weather was not very favorable, guys. We were hearing a 40% chance of go here, so they might not do it. We'll see.
3, 2, 1.
Go for launch.
Send it. Oh, that was a good day, man. That was an even better day.
Stage separation
Jellyfish.
confirmed. Dragon, separation confirmed.
Stage 1 is transonic. Landing legs have deployed.
That's nice.
And Falcon 9 has landed.
SpaceX.
On screen is a live view of Falcon 9 awaiting its liftoff from Vandenberg Space
Andy?
Force Base's Space Launch Complex 4 East about 9 minutes from now. This afternoon's launch is our 4th launch from Vandenberg this year. Good afternoon, everyone. My name is Andy Tran, and I'm a quality engineer here at SpaceX. I'm joining you today from Hawthorne, California, which is about 170 miles from our West Coast launch pad that you see on screen. On today's flight, we'll be taking another 53 Starlink satellites into low Earth orbit in order to expand our coverage around the globe. A bit later in the webcast, we'll share a couple of updates on our growing coverage in Canada and across Europe. But before we get to that, we wanted to recognize a handful of celebrations during the month of May. Not only is it the month for sending Star Wars-themed memes and celebrating the amazing women and moms in our life, it's also a time when we recognize and celebrate all the incredible contributions made by generations of Asian Americans and Pacific Islanders. These contributions have had a great impact to our history, society, and culture. Here at SpaceX, our Asian American Pacific Islander Employee Network is hosting a variety of events where we'll celebrate traditional cuisine, movies, and other fun activities. So be sure to take some time this month to send love to your Asian American and Pacific Islander friends and neighbors. For now, let's take a closer look at our Falcon 9 on the pad. If you're not familiar, Falcon 9, also known as F9, is a two-stage rocket and the first orbital-class rocket capable of reflight that is designed and manufactured by SpaceX. F9 stands 70 meters tall, which is almost as tall as the Taj Mahal in India, and is named after the Millennium Falcon from Star Wars. The Falcon 9 that you see on screen rolled out to the pad Wednesday morning and then went vertical a few hours after that. This particular first stage has supported 4 missions: NASA's Double Asteroid Redirection Test, or DART, the Sentinel-6 microfluidic mission, and 2 past Starlink missions. If you've been following SpaceX, you know that reusability is one of our top priorities, as it's the key to reducing the cost of space access for all of us. And being able to reuse multiple components of our rockets plays a big part in making that a reality. In addition to the Star Wars aspect to the name, the number 9 in Falcon 9 references the 9 M1D engines on the first stage, but there's actually 10 engines on the rocket. The second stage has a slightly modified engine on it called the Merlin Vacuum, or MVAC engine. This engine has a larger nozzle which allows the second stage to perform better in the vacuum of space. And much like an assembly line, each part of the rocket plays a very important role to the launch. While the first stage powers us up and out of the Earth's atmosphere to space, the second stage takes the satellites to their targeted drop-off orbit. We just heard the callouts that
Stage 1 RP1 load is complete.
Engine chill has begun, and second stage thrust vector control actuators should start within the next few minutes. These are also known as the engine wiggle test. We move the thrust chamber slightly to make sure that the guidance hardware is a go for flight. The first stage would do the same wiggle test just seconds before ignition.
4 times on this one, Carmen.
The large barrel structure with the pointed nose that is on top of the second stage is the payload fairing. It's composed of 2 halves made up of carbon composite material that come together to protect our satellites until we're in the vacuum of space. Around 3 minutes into flight, once we've exited Earth's atmosphere, we will jettison the fairing halves and attempt to retrieve them once they return to Earth. We want to jettison the fairings as soon as we can, as the weight of the fairing actually decreases second stage performance. And for reference, the payload fairing is about 40 feet tall with a 17-foot diameter. To put that size,
looks like a pistol bullet
inside both of the fairing halves.
Yep. Those fairings are gigantic.
And as those fairing halves return to Earth, so will our first stage, which is set to land on our drone ship that you see on screen. This one is named Of Course I Still Love You, and it's currently positioned near Baja, Mexico today. If successful, it will mark the 112th recovery of a Falcon 9 first stage.
Okay.
So the call we just heard is we're beginning to pressurize for retracting of the strong back, which is part of the transporter erector, or TE. The transporter erector's job is to roll out the rocket to the pad and raise it to that vertical launch position that you see on screen right now.
This is the 154th
Now, in order to
Falcon 9
retract the
launch?
strong back, we're going to be opening up the clamp arms right underneath the fairing halves. Once those arms are open, then we begin to recline that strong back away from the vehicle to its pre-launch position. And as we get closer to T0, it will continue to recline away, providing clearance for Falcon 9 to lift off. So if you look closely behind the the white clouds there, you can see that those clamp arms have indeed opened
And
up.
this
and
whole
we
thing
should
is
start
gonna
to
go,
see that strong back
this
begin
way.
to recline away from the vehicle.
It'll
There it
move
goes.
to 87 degrees off the rocket. So if the rocket's at
So
90,
as that's
it'll
happening,
move
if
to
you've been
87.
following Starlink development, then you know that Starlink is a constellation of multiple satellites in low Earth orbit and has the potential to service the entire globe. Because Starlink does not rely on traditional ground infrastructure, it's great for places where connectivity has typically been a challenge or non-existent. Earlier this week, the government of Quebec, Canada announced it will fund the deployment of Starlink in up to 10,000 homes throughout the province. The grant is part of a program that aims to extend high-speed internet access throughout.
Vulcan, no strong back goes to 87 degrees. The other ones go to 89. Yeah, sorry, I flipped the two numbers around.
Homes by the end of this September. Starlink has also gone live in Greece and Hungary. These additions bring us to servicing a total of 36 markets around the globe. If you're wondering when service will be available in your area, yesterday the Starlink team released an updated Starlink availability map. You can enter an address or just zoom into certain areas on the map to identify locations that have active service. The areas in light blue are locations where you can order immediately, and where there is a wait list, it'll tell you the current expected time frame for service availability. If you'd like to check it out for yourself, you can find it on the Starlink website at starlink.com/map. So we are about T-minus 2.5 minutes. Falcon 9 is now moving into the final stages of the countdown. We've got some clear skies out in Vandenberg. We are watching for ground wind speeds as we get closer and closer to T0.
I don't know, username, I wasn't looking. Okay, so you see a lot of condensation coming off the rocket. What's going on is because the fuel is not necessarily cold. So you can see where the fuel tanks are, the parts that aren't smoking on the vehicle. But Falcon 9 uses semi-cryogenic propellants, so it uses basically RP1, which is like, it's basically jet fuel. It's like jet fuel, kerosene, and RP1 are all kind of part of the same family there. Something that's kind of like, it's kind of diesel almost, right? That's not cold. You don't need to freeze that. It helps, and it's getting some residual cold from the stuff that actually is cold. That's the liquid oxygen that's in here. The rocket goes all the way up into space. There's no oxygen up there, so rockets need to bring the oxidizer with them. They got to bring the oxygen with them. It's easier to bring it in liquid form as opposed to gas form. So there are parts of the rocket that's really cold. Because the propellants are so freaking cold, for oxygen to exist as a liquid, it needs to be really freaking cold. And because of that, Falcon 9 gets cold. And it's the same kind of thing, it's the same kind of phenomenon that if you take a cold drink out of the fridge in the middle of a hot day, it starts to condense. Same exact thing going on here. It's literally freezing the water that's in the atmosphere, the water vapor in the atmosphere. That's why you get that condensation. Now, the vent that's coming out over here, that is a purge down. The fuel lines, the fuel and oxidizer lines for the second stage are inside of this thing. They're actually down here. They're inside of the transporter erector. And what they do is, well, they don't want fuel in this thing when the rocket goes to launch. So they hit it with a purge down system, and that they purge it out. They basically pump gas out, and all the liquid oxygen comes shooting out of this tube right here, but when the liquid oxygen hits the atmosphere, it goes right to gas. So
T-minus 15 seconds.
Purge down is complete. We're inside of 10. Let's go. See what happens.
10, 9, 8, 7, 6, 5.
Sound suppressors
4,
are on.
3, 2, 1, 0. Ignition.
Okay, we're flying.
And liftoff. Go Falcon, go firm.
Ooh, that microphone got blown out.
Pitching downrange.
Okay, everything looks good. It looks like
M1D chamber pressure is nominal.
It looks like a good day to fly, but supposedly it was really windy, but they said send it anyway, so let's see what happens. It may have, I'll also note, it may have been the wind. It may have been the wind that blew the mic out, not the rocket. Maybe the wind plus the rocket blew the mic over.
Acquisition of signal, send equal time.
We are T-plus 42 seconds into flight. Falcon 9 has successfully lifted off from Space Launch Complex 4E, carrying our 53 Starlink satellites into space. Moments ago, we began to throttle down those 9 engines on the first stage in preparation for a period known as max Q. This is where the vehicle will experience the highest amount of aerodynamic pressures.
Peak aerodynamic load. It's basically when the rocket can't move the air out of the way fast enough. It starts to compress.
That was the confirmation of max Q.
You don't want to
Coming
compress
up in about a minute, we have a series of events happening back to back. First up is MECO, or main engine cutoff. This is where the 9 engines on the bottom of the first stage will shut off in preparation for stage separation. This is where the 2 stages will separate from one another, with the second stage continuing with SES-1, also known as
MVAC engine chill.
Second engine start 1, where that MVAC engine on the second stage will ignite and continue to carry our Starlink satellites to orbit. And then shortly after SES-1, we'll have fairing deploy, where the 2 fairing halves on the top of the second stage will jettison themselves and make their way back to Earth. The first stage, after stage separation, will also be making its way back to Earth to land on our drone ship. Again, it's currently parked off the coast of Baja, Mexico, waiting for this booster's 5th landing attempt.
You can almost see the bay up there. There's some clouds behind it, but you can see up to Monterey Bay.
For now,
and
we are
the
enjoying
Bay
some
Area.
gorgeous views.
It's crazy.
Of the West Coast, as things continue to look good.
There's
for today's mission.
Pacific Coast Highway up there. This is a look up the business end of the second stage here. You'll get the call for main engine cutoff, and you'll see the second stage separate if they keep that camera. This one's going out of
Main engine cutoff.
Okay, there's the call for MECO.
Stage separation confirmed.
There we go. Picking up the business end. Watch for engine ignition.
MVAC ignition.
Stiffenering. Good. Perfect. Everything looks real good. Stand by for the fairing.
Fairing separation.
Good.
And again, continuing with the gorgeous views, we saw a ground shot of main engine cutoff. Now on screen on the left-hand side is a view of the first stage booster. It is making its way back to our drone ship.
Right there.
The right-hand side of your screen is a view of our second stage Merlin vacuum engine. The fairing halves have
Santa Barbara right there.
Deployed,
Malibu.
And so we have our
Santa
Starlink
Barbara's right
satellites
there.
exposed to
Malibu.
the vacuum of space. They have a couple more minutes to go before we actually shut down that second stage engine and
Catalina Island's
insert
over
our
here,
second
so.
stage and the satellites into an orbit.
So LA.
The fairing halves, again, are going to be making their way back along with the first stage for recovery. The first stage needs to execute 2 burns in order to make its way back to our drone ship. Of course, I Still Love You.
Yeah.
First is
Nice.
an
You got
entry
out
burn
quick.
that's coming up around the T plus 6.5 minute mark. This is a 3 engine burn that slows down the first stage before we hit the denser parts of the Earth's atmosphere. And then around the T plus 8 minute mark, we'll have the landing burn. This will be the final burn before our landing attempt for the first stage. And this one is a single engine burn. T plus 4.5 minutes into flight.
Raider.
Engine performance on the second stage is nominal.
Thanks, Raider.
If you look closely on the left-hand side of the screen, you can see some
Gotcha, man. That's my
puffs of
job.
gas. That is nitrogen from our attitude control systems. That nitrogen will help
Thanks for the
to
tip, dude.
orient our first stage properly in order for it to land.
Oh,
and you
boy.
also notice that we have 2 of our 4 grid fins on camera right now. Those will swivel
Broomstick and
and
trampoline.
Vehicles are following nominal trajectories.
I'm
those
gonna
will
go over
swivel
here
and
so
help
you
to
guys can see
guide
this better.
and steer that first stage back to our targeted
Okay,
landing.
yeah, I'm just looking around. Everything looks fine here. I'm looking at the map. You even got a really nice view here. What is the recovered number total for Falcon 9s? It's over 100, easily.
If you are just joining us, we successfully lifted off from Space Launch Complex 4.
How far does the first stage travel downrange? Downrange is about 600 kilometers, 400 miles. 400 miles. This thing is south, like, okay, so Vandenberg is a little bit west of like where LA and San Diego are, right? So if you guys are like looking at a map, you have LA, you have San Diego, and then there's the Baja Peninsula, there's Tijuana below San Diego. It's below Like, it's out by the Baja Peninsula, so south of Tijuana. It goes far. That first stage flies. I mean, the apogee on the first stage, so its highest point is, I don't know, like 400,000 feet. 400,000 feet up. It's about like 120 kilometers up there for the metric folks. It's way up there. Like, way up there. Like, dude, that thing is clear into space right now. You can, like, look, you can see the gases in the atmosphere. That's what that haze is right there. And it's going to come back down here in a second. And it's going to start to hit that. It's going to start to hit these gases in the atmosphere. You think that's air you're breathing now? And that's going to create a lot of... Spark! 10 subs. Thanks, man. And Joey with 100 bits. That's going to create a lot of compression. That thing's going to come in, and it's going to hit the atmosphere really, really hard, and the gases are going to compress up against the bottom of Falcon, right? So that compression, because if you compress a gas, it gets hotter. If you decompress a gas, it gets colder, right? That's called the ideal gas law. If you compress gas too much, it basically divides by zero. You start ripping atoms apart, or, well, not ripping atoms apart necessarily, but it ionizes, and it creates a ton of heat. That's what reentry heating is. Falcon 9, if you looked, it just fired its engines. Falcon 9 fires its engines at that compressed air and pushes it away from the vehicle. The rocket firing its engines is the heat shield. That's my favorite part. It's the most metal thing ever. Literally fighting fire with fire. It's actually fighting plasma with fire, but, you know, that's fine.
You get successful...
Supersonic retro propulsion is what it's called.
Confirmation. We will be
what is it called?
We'll have audio up.
See,
if you want
look,
to
there's the
follow
entire
along.
Baja Peninsula
We'll
right there.
deployment
That's
of our
really
satellites
cool.
Via social media.
He said the thing. He said the thing. The second stage is looking good. Okay, stage 1 is below the sound barrier here.
About
Pull,
20 seconds away from the beginning of that landing burn.
Laserman gifted
Second
2.
stage performance and trajectory continue to be nominal.
So T1. Okay, they have an LOS. It went over the hill from Vandenberg, meaning that the Falcon 9's too far down range. They can't see it because there's an Earth in the way.
landing burn.
Okay, landing burn on the first stage.
So
Thanks, Bill.
We heard that we have begun the landing burn. Hopefully we can get footage.
Stage 2 FTS is safe.
Of the first stage landing on our drone ship.
Fight fire with fire. Okay, we got a shot on the drone ship
Stage
here.
1 landing leg deploy.
Landing legs have deployed. You
There's
should
a
see
view
it
of our
here.
drone ship positioned off the coast of Baja, Mexico.
Hello?
Expecting that first stage booster
We got a loss of telemetry.
to land here shortly.
Stage 1 landing confirmed.
So we have
okay.
video confirmation.
There it goes.
On the first stage.
It's cool.
That is the 5th successful landing for this particular booster, and the 112th successful recovery of a Falcon 9 first stage booster.
112.
We also heard confirmation
Thanks,
of a
Pembo.
successful second engine cutoff.
Stand by for the NOI confirmation.
Loss of signal. SNI.
Okay,
Nominal orbit insertion.
Nominal orbit
And
insertion.
that was the
Bingo.
final call out that we're waiting for.
Bingo.
A successful orbital insertion. With the confirmation of both successful second engine cutoff and a good orbit, we'll be ending our webcast for today's launch. For those of you that are interested, we'll be confirming payload deploy via our
Got a
social
good first
channels,
stage landing.
So keep an eye out for that.
It looks like that may have been a little
Alternatively,
rough.
If you'd like to follow along through
That stage is a little rough, dude. It's not on the center. Usually, I mean, sometimes that doesn't mean anything, but we had a pretty nasty loss of signal there.
Don't worry, we're currently targeting another Starlink launch tomorrow, May 14th at 4:40 p.m. Eastern time. So be sure to tune in. And
There's
we'll
another
see you
one.
next
They're
time.
going to send another one tomorrow because they can. It looks like that landing may have been a little bit rough. The signal was disrupted on the first stage. We had a loss of telemetry. Now, okay, so how do I know? How do I know? The eject, what do you mean? What do you mean? So if we go back and look, these numbers right here are right off of SpaceX's telemetry. These are the real numbers. We know because if you look at the differences between loss of signal, acquisition of signal, these numbers update. So those are real. Those are the real numbers. That's the telemetry of the rocket. That's what it's doing. But there was a loss of telemetry here. There was a loss of telemetry during landing. Now, don't get me wrong. It landed. We got it back. That's what's important. But yeah, we did lose it. We lost its telemetry at 8.1 kilometers up, going 1,500 kilometers an hour. That's pretty fast. Oh wait, now I'm at an altitude where Starlinks are visible. Yay. a 50th landing on Of Course I Still Love You. I've noticed they are doing more shallow trajectories with Falcon upon entry burn and splashdown, especially with Starlink missions. Yeah. Really don't like that they don't mention the missions that the fairings flew. Yeah. The seas did look a bit rough. It looks like that booster came in a little bit hot. There's a lot of stuff on the camera, so to speak. Let me take a look, see what else we could see. The engines are, so what they're doing here, if you see like gases coming out of the motors down there, what they're doing is they're purging the engines out. Why do you do that? You hit the engines with helium after you fire them. Why? Okay, why do you do that? Well, you want to put any fires out. Rocket engines tend to make a lot of fire. I know. But sometimes you have residual propellant inside of the plumbing in the rocket engine. So if you ever had a garden hose, you turn the garden hose off, right? And if you jump on the hose, it shoots water out. There's residual water trapped in the plumbing, right? Rocket engines actually have the same thing. The problem is that your residual water explodes. Yeah, it likes to catch on fire. So what they do is they hit it with helium. They start pumping helium through the entire, just flowing helium gas basically through the entire plumbing system on the Merlin engines. And that basically gets everything out of them. That gets all the liquid oxygen out, and it gets the RP1 out. Now, okay, is that it? Is that the only reason? No, there's another reason. Liquid oxygen. Liquid oxygen. It oxidizes things. Yeah. Liquid oxygen makes things rust really, really bad. Now, don't get me wrong. When it's flowing, it's not that big of a deal, right? But if you left a bunch of liquid oxygen in this thing, right, and then you didn't purge it with helium and you just left it there, you come back the next day, there will be no rocket. It'll literally rust into the ground. Not a day, but you get the idea. It'll rust it to a point where it's not usable. So that's the reason you see these little vent lines out here. They're purging out the engines to make sure that they get all the corrosive oxidizer that oxidizes things out of it. Yeah, I know. It oxidizes it. And the reason why I say corrosion or oxidization or rusting is because there's different components on the rocket engine. There's all kinds of metals on that thing. There's aluminum, there's steel, there's Inconel, there's a bunch of stuff in there. And all of those will react differently with liquid oxygen. So, it's not a big deal when the engine is on, right? It's not that big of a problem. But when you shut the engine off, you're going to get residual. And that, like I said, the residual can cause fires, but more importantly, it can rust the engine from the inside out. So if you see them venting down gases here, that's what's going on. You see it right there? It's hard to tell because the camera... Yeah, see, there you go. Was a little worried for a Friday the 13th launch. It was a 40% go probability on this, which is... And I'll be honest with you. That booster looks like it came in rough. Now, how can I tell? The engines are a little closer to the ground than normal. It might just be the camera. And it's a little bit off-center. If Falcon 9 comes in a little bit off-center, this suggests windage. Sometimes that happens. It's really hard to stabilize a rocket, especially when it's in its final, terminal descent. Because once you get below, once you get below, 100 knots... With the launch vehicle, with the first stage, the grid fins that are steering you don't do anything anymore. This is why airplanes, for instance, need a runway, because going down the runway, you got to get enough air over those wings for them to generate lift, or else they don't do anything. The grid fins basically stall out because the grid fins are designed to move air at 5,000 miles an hour. Yeah, so when they get to 50 miles an hour or 100 miles an hour, they don't work very well. So you're entirely relying on the rocket engine's thrust vectoring or gimbal to steer you in. So if there is some windage, if there's some wind shear, right, the thing, it'll blow the vehicle, the whole thing to the side. Because remember, for the size that Falcon 9 is, it's absurdly light. Because most of it is fuel tank. 98% of this thing is fuel tank. And the other 2% is engines and landing legs and stuff. So it has a high coefficient of drag and a very low ballistic coefficient. Now, if that meant nothing to you, basically think like a balloon. It's really easy to blow it around. Same idea. So sometimes that wind can make the thing come in a little bit hot, and that looks like that is what happened here. Now, don't worry, it's not going to damage the vehicle too much. They have a shock absorber built into the 4 landing legs. They're actually right here. There's a shock absorber built in, but it's not a hydraulic shock absorber like what you'd think. That's too much mass, too heavy. It'll screw your performance. They don't have a pneumatic system either. It's actually just aluminum. It's aluminum that's in a honeycomb. It's like a crumple zone on a car. There's crumple zones at the bottom of the pneumatic struts right here. There's a crumple zone, and that's your shock absorber. They're using a pneumatic strut as their spring, and they're using an aluminum crush core as the damper. So Falcon 9 has a little bit of leeway when it comes in. You can always tell if a booster had a higher vertical speed when it shut the engine off by how much that crush core is crumpled in. And you usually can tell by how close the engines are to the deck of the drone ship. The angle here, I've watched a lot of these things land. I've watched almost every single one. The angle right there is a little much, implying that there was some wind and this thing came in a little bit hard. But yeah, that just speculation. I'm not sure. Like, I'd need to look at the telemetry, and I'm not getting the telemetry because I'm not SpaceX. I do have a shirt like this in real life, though. I missed it, but there was some talk in NASA Space Flight about seeing the fairings in the booster cam. I didn't see that, Bill, but yeah. The lunar module used them as well that NASA used to land on the moon. Yep. Anyway, that was the Starlink launch out of Vandenberg. There literally is another one tomorrow, and I think SpaceX has one teed up again on the 18th. So there's one tomorrow, and then there's one next Wednesday. And then there's another rocket launch. There's an Atlas V next Thursday launching a Boeing Starliner capsule. So there's still plenty of launches here in the month of May, and I will be covering all of those. I cover every single rocket launch that we can get our hands on, within reason. The entire booster recovery fleet is out for Starlink missions. Crazy. Yeah, every SpaceX launch gets covered. Most American launches get covered unless they're at like a really absurd time. But yeah, I try to be here as much as I can because rockets are freaking cool. And not a lot of people out there know a lot of rocket science, right? But my theory is that about rocket science is pretty easy, actually. It's pretty easy. That someone will take that out of context. Rocket science is pretty easy. It's easy to understand. It's hard to do. Okay? It's difficult to do. I understand rocket science. Look at me. I'm an idiot. Like, what do you want? I wouldn't do rocket science unless I, was gonna lose a couple fingers or something. It's easy to understand it. It's not as hard as people think. If you understand the basics, you understand how physics works, like basic physics, you can understand rocket science. It's not too bad. It's actually going and doing it. That's the tough part, So, yeah, you can come here, watch some rocket launches with me, learn a couple things about physics. It's pretty cool. So, yeah, we'll be doing that again tomorrow.
Discovery.
Anyway, I hope you enjoyed the coverage. For anybody that's coming in from the science and tech category, I run a space news cast pretty much every day here. Tuesday, Wednesday, Thursday, Friday, Saturday. And we are currently looking through what's going on with SpaceX's Starship, and we got interrupted by a SpaceX launch. I'm starting to notice a pattern here. I don't know what it is. Fluid dynamics. Yeah, no problem. Yeah. Fluid, thermo. It's fun. It's fun. Yeah, it's fun. Sure, Tessa. Anyway, I'm going to flip us back over to space news here. The Space and Rocket Review. EJ's Space and Rocket Review. Thanks to everybody that bit-tipped and subbed there. I do appreciate it. The Space and Rocket Review. You two chatters, tell your friends. You, with the hat.
Discovery, go and throttle up.
Oh, Strout, there's another 5. SpaceX, so sorry to interrupt. Still can't wait for the amazing Starship launches and landing to come back. I agree. I think SpaceX can catch those boosters like they say they will. I really do. Scroat, thank you very much. I do appreciate it, man. Supersonic retro propulsion. I have my iRacing Indy 500 tonight. Yeah, after Space News Silent, we're going to be racing Indy for my Friday Night Racing League in Assetto. Yeah, that's going to be fun. Yeah, that's going to be fun. Death. Anyway, so let's get back going here. I'm just going to rewind our footage. So we watched some NASA spaceflight footage here. This is coming from our buddies over at NASA Spaceflight, who we do have permission to review all this. I can review it and put my terrible commentary over it here. So make sure if you want space news about what like SpaceX Starship updates, go check out NSF. Seriously, if you go over there and support them, I can keep doing what I do here and keep putting my terrible commentary over this. So let's keep going. Looks like we got some guys grading dirt here. I already did it, Grumpy. I did it on break. The Boca Chica go. Yep. It's not completely terrible. Okay, only a little. Alright, watch. They were messing with the quick disconnect for the booster. That's where the fuel lines are. The fuel lines and the pneumatic systems for like helium tanks and nitrogen tanks are in this big thing that looks like a... It literally looks like a squid from the Matrix. Yeah. Okay. Mm-hmm. Yes. It's good? Alright, cool. Your words, not mine. Yeah, so SpaceX, for the Starship junkie, SpaceX put 7 back on the pad.
Attention Starbase. Entire pad clear in 1 hour. All personnel, please begin exiting the pad and remove all vehicles from highway 4.
They were doing cryo tests here, so this thing should start to get a little icy. Yeah, that's right, Hunster. Yeah, maybe it is. Hiding in plain sight. Man, that thing is big. So that's the orbital launch mount. That has the rocket attached to it. And then if you're unfamiliar with these things, those are catching arms. So basically, those things actually can lift Starship and the booster eventually. They'll lift it up and be able to put it back on the pad, but also... See that big steel thing up on the left here? This big thing, the rocket? If you're unfamiliar with Starship, what SpaceX is planning on doing is having that booster come back down and hover like Falcon 9 right before it lands on the drone ship that you just saw. Only those things, those 2 arms are going to catch the dang thing. And they're going to grab it while it's hovering and then set it back down onto the pad. That's what they're trying to do. Now, if that sounds a little bit ridiculous, I agree with you. Oh yeah, no, that's absurd. No one's ever tried anything like that, ever. But, if anyone can do it, I think SpaceX can. Next, you tell us that cows can fly. Cows, in fact, are not very aerodynamic. Why are they doing it? Because it sounds impossible. Because it's ridiculous, right? They're doing cryo tests there. Oh, of course. Yeah. Cows are, in fact, not very aerodynamic. Well, I mean, Blue, I can show you if you want. Like, so see the blue? Blue is low pressure. Actually, no, that's well, it's not exactly right. It's not low pressure. It's airspeed. Yeah. That is all. What's that? Nice. Yeah. So there's a lot of drag. Cows, in fact, make a lot of drag. Yeah. No, the blue is the bad smells. Sure. Is it methane powered? It could be. Could be. Yeah. I mean, cows are, in fact, not very aerodynamic. Don't ask me why I know that exists. I mean, there's more analysis on the aerodynamics of cows out there than I really think is necessary. See the swirly boy? That's drag. That's no good. Low pressure, bad. Low pressure next to high pressure is bad. That makes swirly boys. Yeah, like seriously, there's more. There's more out there aerodynamics of cows than I don't really understand why. That was a fast mover. But anyway, here, more cryo tests. Yeah, Laxito, yeah, you're not wrong. I don't think so, Enco. Yeah. Last. The aerodynamics of a cheeseburger. It's actually not too bad. That's actually not too bad. That's not a lot of turbulent air. There is a little, but see the swirls? The swirls is drag. That you're getting higher and lower pressure air mixing, and when they mix, they swirl around. They make vortexes. Yeah, it makes like a tornado. The tornado is not good. Tornadoes make drag. There's another EJ quote for the day. Yeah. But see, here's the thing. You're getting equal compression on both sides. In order for something to fly through the air, you're going to need to get... You really want this stuff to get something to fly. You want this stuff to be up here. That's how a wing works. A wing, like a wing on an airplane, intentionally makes the swirls over the top of the wing. That's what it's supposed to do. So you have low pressure, air moving at high speed. Yeah, it is a cheeseburger, I know. You have low pressure, air moving at high speed over the top, and high pressure, air moving at low speed, basically where these lines get closer to each other, moving over the bottom. Resulting force is lift, lots of it. So the cheeseburger is not going to generate much lift here. In fact, the shape of the upper bun is probably going to cause higher pressure up top, and the cheeseburger will most likely nose down here. You know how you can tell? The lines are closer to each other up here. See? Closer. Now you do get a crazy change right there. There's some high pressure here. So there's high pressure right here, and then there's higher pressure right here. The cheeseburger will nose down in this scenario. Yeah, nose down. Cheeseburger. As soon as you take a bite out of it, won't stay kind of aerodynamic? If you took a bite out of the back, sure. Yeah, absolutely. That'll stabilize it. Like fins on a rocket. You'll make more low pressure back here. Damn it, now I'm hungry. Can we just go back to the... Is that how they get the smoky taste? Oh, yeah. RoboCam sneaks up on an unsuspecting photographer. Hello? That's Nick. That's not loud at all, is it? Wow. How aerodynamic is a hot dog? Pretty dang aerodynamic. I think we got one more video here. Let's go. Once again, coming from our buddies over at NASA Spaceflight. Yeah, Boom, sure. Are they installing Raptor 2s on Booster 7? I think so, Joey. Yeah, maybe. I've heard whispers that they're going to do that, but I don't know, man. I don't know. I like using the footage presented and then extrapolating what they're doing based off of this. Three for initial testing is the rumor right now, with more likely to come later. Yeah, that's just hearsay though, Thomas, right? Like, I wouldn't confirm that. I don't know. Maybe. I think 8's gonna be the one that flies into space, but I could be wrong. How aerodynamic can a rocket get? It depends, Samo. Like, it's not how aerodynamic can a rocket get, dude. It really depends on what you're trying to do. Now, okay, so think about like the Concorde or any jetliner. We'll use the Concorde because it looks cool and it's an awesome plane. Concorde looks very aerodynamic, right? You'd think the Concorde is a fast plane, right? The space shuttle is not aerodynamic. It literally looks like a flying brick with wings. Goes way faster than the Concorde. It's interesting because you can't say like, oh, what's the best aerodynamic? How aerodynamic can a rocket get? It really depends on what you're trying to do. Engineering at its core is basically, what are you trying to do? Like, what are you trying to get done? The space shuttle goes Mach 25. Concorde can go Mach 2. It is a very different shape, but there's a reason for it. So the space shuttle, you think, oh, the space shuttle can go way faster, right? It can go way faster than Concorde. So that's a better aerodynamic shape, right? No, not really. No, it's really, really bad. But you got to remember, the shuttle is designed to fly poorly. Like, I know that sounds ridiculous. It's like, what do you mean it's designed to fly poorly? No, the shuttle's designed to create a lot of drag. It's designed to slow down. It's a re-entry vehicle. Now, don't get me wrong. You can make a re-entry vehicle that doesn't slow down. They usually put nukes on the front of those things. And it hits the atmosphere going Mach 25, and if somebody was aboard, it would liquefy them. Yeah. The deceleration and the heat there would be nothing left. But, like with the space shuttle or a Dragon capsule, for instance, you don't want to do that. They're intentionally built to make lots of drag. Right? They're intentionally made to do that, so the space shuttle, when it's coming through, it slows down. And it's built just good enough to be able to land on a runway. But for the most part, the space shuttle is designed to decelerate at hypersonic speeds, and then down into supersonic, down into transonic, down to subsonic, and land on the runway, and just barely be aerodynamic enough to land on the runway. That's intended. That's what it's supposed to do. So you know, is there a better aerodynamic design? Is there a better this, better? It's really hard to say. Like, it really depends. It's better is subjective. It depends on what you're doing. Does that make sense? Now, in terms of like what you're talking about, how aerodynamic can something get? Like what's the most aerodynamic shape? Well, the most aerodynamic thing is something that disturbs the air around it the least, but still achieves what you're trying to do, still achieves the objective that you're trying to do. What are you trying to do, right? It always comes back to that. So Concorde has that really long, sleek shape. It looks like a spear almost with some wings on the sides, because it's designed, it's supposed to go fast. When you break the sound barrier, you really don't want to disturb the air too much. The lesser you disturb the air, the better, right? That's more aerodynamic. You will make less drag. But you got to remember, a plane still has wings attached to it. Wings need to make differential pressure. You need to make high pressure under the wing, like I just said. You need to make low pressure over the top of the wing. If you don't, your wings don't lift. They don't generate any lift, and you don't stay flying. You go down, right? So it's always a trade-off. It's always a trade-off. What are you trying to do? Concorde has this super sleek fuselage that looks like like a javelin almost, right? But those wings on the side generate crazy amounts of drag. It's always a trade. You know, you have to make drag with the wings. So the wings, basically the wings on it make it fly worse through the air. Believe it or not. But you need them to stay up there, right? You need them to stay up there because if you didn't have wings, you wouldn't be flying. Isn't that weird? Engineering it's counterintuitive like that, but it all comes back down to what you're trying to do. What's better? You have to set some base standards depending on what you're doing to determine what's better and what's not. That's how engineering works. Interesting, right? Yeah, Filcher, everybody says, oh, the shuttle flies like trash. They say it in a way that implies that NASA built something and it flew like crap and they were like, oh, it doesn't fly very well. No, that's not how aerospace engineering works. No, they built it to fly poorly on purpose because it's designed to fly at Mach 25, not at 200 miles an hour. It's all about what are you trying to do? What are you trying to do? Re-entry vehicle. Right? Cursed F4 Phantom, kill it with fire, please. Pigzig, I hate it. I hate it so much. Yeah, Blue, I think they're gonna fly 8 because of Booster 7's repair. I agree with you. Big brain thought, put SN60's nose on 7 and use it as an aerodynamic nose cone for BN7 suborbital testing. Just don't hit the tower. I like the way you think. So this is HVAC tubing right there. They have it up there and it's blowing air on something. I don't know what that's up to. Probably also not built to be flown in Earth's atmosphere. Well, the space shuttle is designed to fly in the atmosphere. It's just designed to fly in the atmosphere up there going insanely fast. Right? That's where it's designed. That's what it's designed to do. It's designed to bring people back down from space. Now that's a hard thing to do, so that's why it's shaped the way that it is. Now, like I said, engineering's always a trade-off. You want to make it fly well up there, it's going to fly poorly down here. It's hard to make something that works really well throughout that big of what's called a transient regime, a transient flight regime. Basically, your environment is changing a lot from the vacuum back down to the surface. It's hard to make something that's good enough to go through all of that correctly. So you have to take a trade-off. You know, does the shuttle need to fly like an F-18? No, it doesn't. It doesn't need to fly like an F-18. What, is it going to dogfight somebody? It doesn't have any engines. It's just a glider. Gliders don't need to be very maneuverable. That's the idea. Makes sense, right? Met not all purpose at the time. In and out is fun. Yeah, exactly. Something like that is. Yeah, right. So what we're looking at here is one of SpaceX's test stands for Starship. These things right here are massive hydraulic jacks. It's a big hydraulic piston. And what they're designed to do, there's 3 on the outside and then there's 3 on the inside right there. What these things are designed to do, what they're going to do is they're going to put a starship on this thing. You can see the bolt point for the starship right here. That slab of metal right there. There's another one over, there's another one over there. What they're going to do here is they're going to bolt a starship to this and they're going to try to crush the bottom of the starship. The idea is to imitate the force that would be applied to the vehicle by firing all the engines. They're using it for testing. Now, the other thing that you see over here, this box is for an umbilical. That's for Starship's umbilical. So this rectangle that rectangle right there would be carrying the fuel lines. Yeah, and I think they installed the fuel line connector on it today. We'll see that in the footage tomorrow. So that's a concrete pumper truck right there, I think. No, the pumper truck's back here. What is this thing? Is that a septic truck? Is that a septic truck? It's a septic truck, isn't it? Oh, helvete. Jag satana. That truck sucks poop. Yeah, the pumper truck is back there. They're pouring concrete over there. That's what this thing is in the background. That's a septic truck. That is a poop truck. It's seriously, that's what that is. I was looking at it, I'm like, that's a pumper truck? No, that's not that. It's a different kind of pumper truck. Either that or a vacuum truck for clearing trash. Yeah. Honey wagon. Oh. What's the name for this truck? No wrong answers. Oh, hold on. Commodity truck went by. So, that truck is carrying liquid nitrogen. It's refrigerated. You can tell because of the way that it is. That's going over to the pad. They use nitrogen for testing because liquid nitrogen is a cryogenic. It's cryogenic. It's really freaking cold, and it's good because it's inert. It doesn't react with stuff like hydrogen or oxygen would. They tried filling something with hydrogen once, and yeah, that didn't end well. So they use nitrogen for testing. That one's going to the pad. Booster 4. Yeah, it's also very inexpensive. It's what, 200 below? It's cold. Yeah. I guess you could say it sucks. Well, as you can see, it sucks. And it cuts. It certainly does suck. The Hindenburg was a great idea until the point where it wasn't. Well, actually, you know, little fun fact about the Hindenburg. The Germans wanted to fill the Hindenburg up with helium. Guess where they got their helium from? The US. And then, then we decided, well, you guys are a little, it's the late 1930s. You guys are looking a little sus. No more helium for you. So they filled it up with hydrogen instead. Yeah, there's an engineering decision here. There's some engineering ethics involved in here that's on the Germans' part. The engineering ethics are as follows. If you designed a blimp to be filled with helium, and then you just decide to change it to hydrogen without doing sufficient tests that the hydrogen could, ignite if there's a hydrogen leak. Yeah. And then you just sent it anyway. It turns out that you're that's called less risk aversion in engineering. Yeah. You're becoming less risk adverse. Meaning, just send it. Yeah. Just sending it, well, a fun thing to do, usually with engineering, that usually ends with something getting broken or someone getting killed. Yeah. You don't want to do that. You don't want to do that with when people's lives are on the line. That's not a good idea. We've learned that over time. But yeah, interesting, right? Yeah, you didn't know that. Yeah, they also made the paint out of the same stuff that they stabilize solid rocket motors with, just by coincidence. Yeah. Now, if you painted the Hindenburg and you used helium, it would be fine. But since they filled it with hydrogen with that same paint, if there's a hydrogen leak, that means oxygen's getting into the blimp and mixing with hydrogen inside of the blimp, and if that meets any source of ignition, and then the outer skin of the blimp and the paint acts as an accelerant. That's great. Yeah, really good. Engineering ethics, man. Yeah, don't do that. That's not a good idea. Yeah. See, there's your fun fact for the day. Yeah, Blue, look it up. Yeah, you didn't know that, huh? Yeah, it's kind of dumb, right? I always think of that scene in Ghostbusters. Are you a god? That was really stupid. Right, when someone says you're a god, you say yes! Won't static electricity be a problem at a point? A source of ignition is a source of ignition, 619. Yeah. I don't see any problems with anything EJ just said. Wait, do you mean to tell me it's not the best idea to make your blimp out of thermite? Yeah, I wouldn't do that. Didn't explode. It just burned very quickly. Yes, fast fire. Yep. They just set it out and hit spacebar. Yeah, they curbled it. Yeah, and it didn't end well because there were people aboard. Yeah, I can think of several times in aerospace engineering where they've said, just fly it anyway, it'll be fine. And then it wasn't. Yeah, I can think of several times. And then it was caught on camera. Wasn't me. That's a Lever 11,000 crane. It's big. So that nitrogen truck that you guys just saw, that we saw go by, this is a filling area for it. I don't know if that filling area is necessarily for nitrogen. I think that one might be for methane. And the crane's moving around. It looks like they're positioning the crane to take Booster 7 off of the stand again. Same thing with the HMS Sheffield during the Falklands. The British Ministry of Defense made her haul out of something that burnt very nicely and didn't consider the ship might get shot at and be sent on fire. So along come the Argentinians with their exocets, and then they hit the ship with one, causing a massive fire. Yeah. That's probably not a good idea. Paint. Yes. Paint. Yeah, they're moving the load spreader up. So yeah, they're gonna take this off. It says it in the title. Yeah, I didn't notice that part. Painting the hinges. If submitted, if you know, huh? This guy's working on the chopsticks right there. Yeah, I know, floating. Funny concept. So they moved 20. This one with the tiles on it, the shiny one, or the shiny-er one. What's next for SpaceX? Another Starlink launch tomorrow at 4, Kuro? Yeah. Dooley. Starlink antenna, it looks like, over there on the left. That's the high peepo bay, and the one next to it is the wide peepo bay. PM 619. Tomorrow, basically, during the start of Space News, we got another one. Wait for it. Another one. Some guy's taking a grinder to that thing. It's just still weird to see parts of a spacecraft just kind of sitting outside. That's. I mean, it's a test article, but still, it's a little strange. Nice, God. There you go. Why don't they have a proper bathroom by now? I'm pretty sure they do. Yeah. I don't know what that is. It's got a little crane on it, though. See a little crane up there? I knew that sound. Yeah, you do. Oh, yeah, you do. Oh, they're starting to put up the insulation. It appears siding has begun installation. Well, okay. On a building like this, when you're in Texas, you want it to be climate controlled. You want it to be climate controlled because I'll let you in on a little secret here. If you're not from Texas, I'm not from Texas, but I know this. I've been to Texas once. It gets a little hot. Yeah, it gets a little hot. Also, you want to make sure if you're putting together spacecraft parts that, you know, they don't rust. So the building that you're going to be manufacturing your spacecraft in, you want to be 20 Celsius, 70 Fahrenheit with like no humidity. It needs to be really dry in there. You'll be able to manufacture stuff better at a, you know, warm temperature with no humidity. You don't want moisture getting anywhere. So what they're doing here, that's not siding, that's insulation. That is industrial insulating material. Okay? You got to put that stuff up first, and then you put the cladding behind that. You put the corrugated steel behind that, and that will keep the, well, in the case of Texas, because hot, it'll keep the cold air in, and it'll keep the humidity out. Because spoiler alert, again, spoiler alert, when you're near the ocean, closer to the equator, probably the closest point in the continental U.S. to the equator, other than maybe like Key West, gets a little humid. Yeah, you want to keep that out of there. Hot air, get out. How's 16 going? People are just dying to get at that thing, Mutter. Starships are just dying. They took it apart. It's dead. I was a best man at my friend's wedding outside in Texas in July. Oh, that's bad. Yeah, so that's insulative stuff. Oh, I'll tell you guys, the other reason why I know what that is because, you know, that garage, yeah, it has that. Yeah, it's that kind of building. Just saying. Oh, Newt, you must have been cooking. A garage. Yep, see, there's your insulation. And then the corrugated steel goes on the outside. There you go. Floating's like, oh, 48, yeah. That's how, dude, it gets hot in Texas. You know what the interesting thing about floating, so like, you know, if you're from overseas, right, you don't know about that part of the country or that part of the world, right? In Texas, you can get sunburned in the wintertime. I know that sounds dumb, like, but the sun, even though it's not as cold, the sun still comes up and you can get sunburned. Like, my brain associates sunburn with it being hot out. No. That's not how that works at all. In Texas, you know, it could be 70 degrees out and you'll feel nice and comfortable. You could be in the sun all day. You will get sunburn. You get sunburn when it's cool. That's weird, man. Now, don't get me wrong. Anybody that lives out in that part of the country is like, yeah, EJ, of course that happens. Well, dude, that doesn't happen up here. It's either freezing cold and you don't get sunburned, or it's really, really hot in the summer here and you do get sunburned. All right? My brain associated getting sunburned with heat. That doesn't necessarily happen. Interesting. Yeah, no, I know, because I went to Texas in November once to watch the Formula 1 race at Austin, and it was nice and cool out, and I still got sunburned, and I'm like, wow, yeah, well, there's an important life lesson here somewhere. The worst experience was 38C and you wanted to die. Max, it gets... Florida gets pretty damn hot, dude, and it gets humid. It's oppressive, but I like the humidity, so whatever. Yeah, okay, so that's 24. They yeah, they stacked it, okay. Yeah, dude, I got a sunburn in November, and my brain was like, what just happened? And then I went... Dude, and then we flew back home, right? We flew back home in November in New England, and it's freezing. It's freezing, and I got a freaking sunburn. I'm like, ow! And then you got to put on a freaking winter coat. I'm like, the back of my neck. Dude, it was terrible. It was freaking horrible. Yep. That sucked, dude. It was so bad. Oh, it was funny. It was pretty funny, but it sucked, man. It wasn't fun at all. Okay, what do we got here? That's a part for the wide peepo bay. I've heard a lot of Yankee whining. Are you talking? Yeah, this is another Libra 11,000 right there. So this crane has jibs on it, jib masts, because crane nomenclature is borrowed from sailing, believe it or not. Those two little thingies sticking out the back, those are the jibs. This is a boom extension right here. And it's used for getting stuff up and over on top of, I don't know, a tall building. Yeah, see? There's the jibs. Are you talking? Shut up, Richard. Yeah, those are, looks like roofing joists. Yeah, once again, I was saying before, note that the roof is angled backwards. That's for drainage, see? If you look at the spacing between this beam and the roof joist right there, see? It gets smaller and smaller and smaller over time. That's so if it rains, all the water goes off the back. It doesn't pool. You don't want water pooling on a roof. That's bad. Physics. See? 11,000. There's a 1 behind the stabilizer right there. I also thought it was really cool. Just on a side note, note that the cab for the crane is actually itself on a hydraulic, and you can actually move the seat up. It's like if you're looking up, so you don't have to like stick your head out. Look, the whole thing just reclines. But can your crane do this? Also, there's another Starlink antenna right there. No, Kuro. I still think they poured concrete up there. I think we just missed it. They can droop the snoot. Second burn of the MVAC complete. Deploy coming up. Gotcha. Powerade. Powerade not only quenches your thirst better, it tastes better too. Powerade. Powerade. Alright. There's just a rocket engine just sitting outside. Whatever. Water sucks. It really, really sucks. Water sucks. It really, really sucks. No, stop saying that. You bad people. Real men drink White Claw. I love that movie, Gaw. From Powerades to Powerhead. I wonder what's in here.
Go and throttle up.
Yeah, UTF 12 CCF. Yes. Yeah. I don't know what those are. It's got electrolytes. What the frick is an electrolyte? I don't know. It hasn't, though. No, Colonel Sanders, you're wrong. Mom is right. What about Brondo? It's got Menergy. All right. Anyway, that's all the Starship footage. It's what plants crave. Uncrewed test flight? Yeah, I'm not sure. Tell me water sucks when the same chemicals are sending you to space. So you want me to drink kerosene? Or... What's up with the Mars drone? Did they find it? They found it again, but its ingenuity is on its way out, Mycon. Have you seen this game? No, but I've seen some typos. Lol. No, I'm just kidding. What's this? Oh, tin can. Yeah, people were telling me about this earlier while I was crashing my 737. Think more RS-25. Oh no, I know. More lights than your body has room for. Water does not suck. That's the answer. You know what sucks? Donkey Kong. You're a Donkey Kong. Mortal Kombat on Sega Genesis is the best video game ever. I disagree. It's a very good game, but I think Donkey Kong is the best game ever. Donkey Kong sucks! You know something? You suck! Got him. You know what DK stands for? Donkey Kong? Drift King. You know what Mega... Nah, I ruined the joke. I'll say it anyway. We're here already. You know what really sucks? Mega Maid. Love that movie? Yeah. It's pretty good. Max, this thing makes like 600 horsepower. It has a Borla exhaust system, and I think it could do 0 to 60 in like 3.2 seconds. Wow! You can read the brochure. It's the best part, man. What's the password? I don't know. You gotta check my luggage combination. Starfield was delayed. Yeah. Did you sound that Sparko steering wheel? Nah, that's mine. I even pay retail for it. Alright, guys. I think we're good on the space news. There's really not much today. We went through cheeseburger aerodynamics. That's good. We went through ships moving around. We do have another launch tomorrow. Space squirrels are in fact real. Yeah. We started space news with that, and we'll. You know what? We will in fact end space news with that. Check it out. Yeah. Yep. Yep. What about pizza aerodynamics? Can you toss it like a frisbee? Sure. Yep. Yeah, this isn't Photoshop, guys. This is actually Twitter. Yeah, just thought I'd let you know. This is actually Twitter. I'm your bad boss. I'm your bad boss. Proud bad boss. I think I actually got everything. I have an old vinyl record called Music for Space Squirrels. Anybody have any questions about space news? We actually finished early for a change. Did you go through this? World continue. Let's see. Work continues to return Artemis 1 moon rocket back to the launch pad. Yeah. Phil, we basically went through the presser for that. Already talking about the NS-21 patch. This post-flight blue talks about what everything means on it. Word. I don't care, Jackal. You can talk about it if you want, but I don't care. Everything I know about the Johnny Depp Amber Heard trial was information that I did not seek out. It was information that was told to me non-willingly. So, yeah, I don't care. Sorry, I only have so many fricks to give, and celebrities getting their feelings hurt and arguing with each other is not on my list of things to give a frick about. Sorry. Most of that list consists of family, Brimo, spaceflight, stream, truck. Yeah, that's about right. Yeah, that's yeah. Thomas, we got a tweet from SpaceX. What's that?
Tranquility Base.
Deployment confirmed. Sweet. Last. Okay. Is there some kind of secret to turning these on? What kind of plane is it? I don't even know what plane it is. Yeah, RB, the engine needs fuel. I figured that out with the 737 today. Mutter's not on the list. Mutter, you a part of the stream, so you were on the list. You were just on the list by proxy. Brimo is included with family, and you put Brimo in there twice. I spelled Brimo with 2 E's once. Yeah, I know, Baxi. Yeah, that's fun, you know. I think. I think I shot the clutch. Your Briggs card isn't getting up to speed. Important question. Would you consider a dog or a cat? Dog. Hey guys, is a... hold on. Is a Thrustmaster Warthog? Thrustmaster Warthog. Is that a good joystick or HOTAS? Yeah? Okay. And okay, second question is that one of those? Interesting. That's a WinWing product. Okay. Huh. Okay. So...
Discovery, go at throttle.
That's a WinWing Orion. So this is what we're talking about here, right? Cyborg, 25-month. Tactical, 12 months. 1 whole year. Thanks, man. So this is what we're talking about? Okay. Oh, wow. Oh, that's nice. That's nice. You're getting into DCS? No. Okay. What you linked? What is that? Mutter. That's an Orion Throttle F-16EX. Damn. You can't afford it. Now you're... Yeah, you're not wrong. There's a flash sale for DCS. I'm just going to leave that on. I already have DCS, dude. Yeah. Interesting. So that's what we're talking about, huh? Samantha Christopher Grady posted this picture of the second stage. Okay, cool. All right. Oh. Oh. Bonus points if you know where that is. What country they're flying over. Well, that's pretty neat. Why? Do you have a line for a Warthog Jeep or something? Turkey? No. It's on planet Earth. Yeah. Spain? Spain? Does the Strait of Gibraltar have that many islands, fellas? Second stage right there. Hokey, yes. Yes. Italy? What part of Italy is that? I know exactly where that is. Let's see. Or at least I think I do. Yeah. Yeah. Where is it? Where is it? Where is it? It's somewhere around here. Yeah. Yeah. Turkey. Yeah, then the border is right there. Cool. You said Turkey, you are a WinRAR. There's Altus and Stratus from Arma 3. Wait, what? Wait, those are... Never played an Arma game. Those are real places? That's... Really? I didn't know that. I didn't know that. I thought this was made up. Ha! I didn't know that. Never played an Arma game in my life. Interesting. Good to know. Dude, they got arrested there for taking photos in the islands and stuff? Yeah, no, I remember that part. I remember reading about that. Yeah. Interesting. Why don't you just use Google Street View? Like, can we Street View out here, or? Oh. I guess not. So, like, Max, you could go to this, like, actual road in Arma? Is that what you're telling me? It's a military island. Oh. Oops. Yeah, you probably shouldn't have done that. Basically. Oh, that's kind of cool, man. Yeah, see, I always wondered why people like Arma so much. That probably has something to do with it. EJ's on a list now? Yeah, I'm flying. I'm not already. Good joke. Wait a minute. So that island is Hellenic, right? It's part of Greece? It's part of Greece? Yeah, okay. Yeah, okay. Yeah, I see. Yeah, I see why. Yeah, there's... Yeah. So, you see these two? You see these two? They don't like each other too much. Chernars from Arma 2 was also based on a piece of terrain in Chechnya. Nice. Yeah, these two. They don't like each other too much. And I'm not talking like some regional conflict. They haven't liked each other for like 2,000 years. Actually, more than that. Yeah, more than that. Yeah, it's more than that. Way more than that, actually. They're in a mutual defense treaty. They gotta be friends. Yeah, that's a good point. Someone stole someone's wife, I heard, or something like that. Yeah, something like that. Do you have Arma 3? I think I have it. I don't seem to ever remember playing it though. Oh yeah, I do. I've played 10 hours of Arma 3. So, okay. I guess so. Yeah, I know. It's not like they've been fighting each other for like 4,000 years. It really is like 4,000. Well, I mean, actually, it's got to be more than that. You only have 4,300 hours. 4,300 hours in Arma, dude. What do you like? Max, I was about to ask, doesn't shooting things get old? But I know the answer to that question. No, it doesn't. I've been playing since 2008. Yikes. Yeah, Joey, exactly. Yeah, it goes long way back if you know your antiquity. You could be a helicopter pilot. Or I could build one in Kerbal and then be a helicopter pilot and make my own helicopter. Every shot is different. Full auto track from Mike Baylor? Oh, let's take a look at that. Let's see. We'll cap off the Space and Rocket review this way. So this is Mike Baylor's auto tracking equipment. This is code with a camera on a pivot that's designed to track the Falcon 9 launch that we just saw. You can mod one into Arma as well. Yeah. It's a nice track. Hey, nice track. Yeah, PIDs, indeed. So does it track the brightest spot and then keep on the center of the screen? More or less, I think. Hey, nice track. Did you watch For All Mankind? I watched the first season. The first season was really good. Second season, I just didn't. Meat Master, that's cool. Oh, that's pretty rad, dude. Third days in a month. S2 is really good. No. No, I don't think so. Why is the cloud forming so far back with the exhaust of the engine and then growing? Heat? Nuclear? What do you mean? Why is the exhaust cloud forming so far back? So you're talking about this thing right here? So that's it's contrail. What's going on is basically this is hot. This is hot. When the hot gas hits the cold gas that's up there, you get this. What? That's hot? Yeah. That's hot. And then when the rocket gets high enough where there's no gas, that's it. Yeah. It's a vapor trail. Mm-hmm. You can tell it's hot because of the way it is. Oh, I thought that was something else. No, it's just a vapor trail. You sure it's hot? Yeah. You're hot. Thank you. The rocket's spreading poison. Yeah, right. Wait, no, that's not what you meant. It's on the internet, Jackal. You can't take it back. I want to see what the track does when it gets to main engine cutoff here. It should be about now. You'll see a nice puff of gas come out. There it is. And then you should see a second stage ignition here. Yep, there you go. There's your second stage ignition. Now you should see the first stage go away. Ah, it didn't go that far. Is that Amish Paradise getting in my suggested? Yeah, it was. Nice. Alright, dudes. That was a good track by Mike. That's Mike Baylor over at Next Space Flight and NASA Space Flight. How was Flight Sim? It was fun. I got the PMDG 737, and yeah, I was having a lot of fun with that thing. I stalled it and crashed it a couple of times, but hey, whatever. Be back for racing for the Indy 500. Right on, Joey. Thank you. Fellas, racing is set to start around 9. I actually might take a break in here, dudes, just because I have to check on house stuff and whatnot. I really want to make sure I'm on top of this, so if you guys don't mind, I'm going to take probably about an hour break here. Just remember, the PMDG 737 requires occasional maintenance. Cool. I'm probably going to take a little bit of a break here. Is the house stuff going good? We're in closing right now, Nikita, and that's a lot of paperwork. It's a lot of stuff to go over. The reason why I want to go over it, guys, is because I have a home inspection tomorrow. We have the building inspector coming and inspecting the house. This is a big part in real estate. This is a big part of closing. This is a big part of the process because we basically have the building inspector will go through and make sure the house is up to the building codes. And if we find something that isn't, well, depending on how bad it is or what it is, basically it protects you against surprises. And if it was something that the sellers had done incorrectly, they might have to fix it, so we don't have to pay for as much. So it's kind of protection for buyer and seller. You know what I mean? So that's a big deal. I'm gonna have to do that tomorrow. Just a reminder, in case you're not interested in watching me race, which is fine. I usually suck at it anyway. Tomorrow.